In this video, we're going to do some more examples of finding derivatives using the rules that we've learned so far. So when you look at this problem here, it says find the derivative of y equals, oh boy, what are we going to do? Well, at first, when I look at it, I say, all right, I have two parentheses that are multiplying together. Okay, does that mean this is a product rule? Eventually, you will be able to do this with a product rule. The problem with it right now is we have a product rule with a power on top of that for one of the terms. So there are too many things going on here. We have a product rule with a function that has a power. We don't have the necessary tools to approach it in this fashion. So right now, we can't solve this unless we use algebra to rewrite it. So what I want you to do is I want you to think about how we could rewrite this problem in such a way that our tools that we currently know can be used to find the derivative. So remember, we're doing algebra, so just write y. All right, take a second. Can you find a way to rewrite this? What does the -1 exponent mean? -1 exponent means that that parenthesis can be brought down to the denominator. If we bring the parenthesis down to the denominator, the power is now a +1, which we don't need to write, it just drops off. So this is now the format of our problem. So by rewriting, we got rid of the product power combination issue, and now we just have a quotient rule. It's just division of two functions. And the functions are functions we know how to take the derivative of using the rules we've learned so far. So how does the quotient rule work? Let's write it down. So the derivative of y is the derivative of the top. Remember, u is the top, v is the bottom, times the bottom, minus the top, original, times the derivative of the bottom, all divided by the bottom squared. So we've got to find all these pieces. So let's do it on the side. So if u is the top, 5t minus 1, and v is the bottom, 6t minus 6, let's find their derivatives. So u prime, what's the derivative of 5t minus 1? Hopefully you've done some practice and you're good to go on this. Hopefully you said 5. If not, go back and look. This is a constant multiple 5 times the derivative of just t or just x, which we said was 1. So that'd be a 5. The 1 is a constant, so it goes away. The derivative of v, the derivative of 6t is the constant multiple times a 1, which we don't need to write. And then the -6 is a constant, so he goes away when you take the derivative. These are all the pieces we need to plug into our quotient rule. So let me write here, we're doing quotient rule. That's the formula we wrote down. We just plug it in. So u prime we have is 5 times the v, that's the original 6t minus 6, minus a u, that's the original u, 5t minus 1, times v prime. Now you can put it at the end or you can put it at the beginning. Okay, so I'm just rearranging the order of the product. Remember, which order you multiply in doesn't matter. It's the subtraction that you have to have right. You have to have u prime times v and u times v prime on those sides of the minus sign. But the multiplication you can rearrange. I did this because it makes it more clear what we're distributing. We're distributing a 5 here and a -6 here. If I put the 6 on the end and I have to put the negative and the 6 together and distribute it, I tend to find it a little bit confusing. On the bottom is the original denominator, v squared. There you go. Now, like I said, we do need to distribute. We need to simplify the top in order to put our answer in MyLab. So we have 5 times 6 is 30t minus 30. All right, now we're going to distribute a -6 times a 5t. That would be -30t. -6 times -1 would be +6. All of this is over 6t minus 6, all squared. All right, are we done simplifying? Can you do some more? I see a +30t and a -30t, so those are gone. And then the numbers, they're like terms. We can add them, or in this case, subtract them, and we would get -24 over 6t minus 6 all squared. This right here is the derivative for the original function we started with. Okay? Here's another example. So when you look at this problem, you need to look at the big picture. What is pulling everything together? What is the glue that's sticking it all together? Is the 11 what's bringing everything together? X to the 11th power. No, that's just on the x. Is e to the x what's bringing everything together? No, that's just the e to the x. What's bringing the 11x and the e to the x together? What's connecting them? Look in between the functions. It's not there, but it should be there. What is bringing these together is multiplication. So what rule do we need to apply? You need to look at the big picture. What's pulling everything together is the overarching rule that you need to focus in on. In this case, that is the product rule. So product rule, y prime, says you need the derivative of the first times the second plus the opposite, the original first times the derivative of the second. Remember, the order here does not matter. Just need derivative times the original plus derivative times original. Which order they are, because everything's added, it's good. All right, so let's write this down. Who do you want to be u? Who do you want to be v? It does not matter in the product rule. So I'm going to call u the first part, because I always call the first part u, and the second part v. So if u equals x to the 11 and v equals e to the x, to finish our rule, our product rule, we need to find their derivatives. So the derivative of u, what rule would you apply here? This is going to be your power rule. Okay, how does power rule work? Power down, x to what's the new power? 1 less, so that'd be 10. So that was the power rule. V is just e to the x. What's the derivative of e to the x? Remember, this is the special one, it's just itself. All right, so this is everything we need to plug into our product rule, and we're going to do that now. So y prime, notice I'm putting the prime because this is the derivative now. U prime, 11x to the 10 is what we found. V is e to the x, plus u, that was the original, x to the 11, times v prime. Well, that's also e to the x. This is one of those random few times where you're going to have the same term repeated. That's only because the derivative was the original, so they're the same. All right, if you type this into MyLab, it might accept it. However, there are other ways you could write it. And eventually, we're going to be carrying on and we're going to be using the derivative to do other things. So it's good to practice writing it in other formats. So what I mean is, let's do some algebra. So this is one answer. Now we're going to do some algebra to write it just a little bit differently. I want you to look at this. Is there any algebra you see that you can do to rewrite this problem? When I look at this, I see two terms. 1, 2. What do they have in common? Well, they both have x's. Take the smallest power. That's how many you can pull out. So x to the 10 could come out. They both also have e to the x. If we take those out of the first term, what is going to be left behind? Just the 11. Plus, if we take 10 of the x's out and e of the x out, what's left in the second term? Just an x. So this is another way to write your derivative. MyLab will probably accept both of them. I imagine they're expecting you to do the red box, but you eventually might need what we did, the green box, to be able to continue the problem and answer some application questions. All right, let's try another one. So if you look at this function, first of all, it's not an x, it's a y, but that's okay. It's still the same concept. We just can't call it y prime equals a function of x. We're going to have to use the notation for f prime to denote the derivative of the function f of y. So make sure you keep your letters straight. It's a common mistake when you go to type your answer into MyLab is to write the wrong letter. So keep that in mind when you have weird variables involved. So let's look at the problem. What do you see that might indicate which derivative rule you will need to apply? Remember, when you're looking for the initial rule, you need to see what's pulling everything together into one. So what I see is I see a top and a bottom, and I see a division or a quotient rule. That is a quotient rule pulling everything together. Inside the quotient rule, on top and bottom, we have rules that we know. We know how to do constant multiple. We know how to do the derivative of e to the x, in this case e to the y. We have a power of y in the bottom. All those are things we can deal with. So overarching, pulling everything together, we need to use the quotient rule. All right, so how's the quotient rule work? First, write it down. You need to memorize it. The derivative of the top first times the bottom original minus, flip it around, the original top times the derivative of the bottom over the bottom squared. So let's write down what everything is. So the top we're going to call u, 3e to the y is on top. The bottom we'll call v, that was 10y cubed. To do the quotient rule, you need the derivative of each. So the derivative of the top, all right, we have two things here, multiplying, but the 3 is a constant multiple. So what does a constant multiple do? It hangs out, chills out, and you take the derivative of the rest. What's the derivative of e to the y? Just like it was e to the x, it's the same thing, e to the y. Derivative of e to the y is itself. V, we have a 10, which is a constant multiple. So he hangs out while we take the derivative of the y cubed. That's a power rule. Power rule says power comes down, and we have a power 1 less. So that would be 10 times 3, or 30 y squared. So that's everything we need to fill in the quotient rule. So quotient rule says u prime, well, that was our 3e to the y, times v, the original v, 10y cubed, minus the original u, 3e to the y, times v prime. I'm going to use a simplified one, so it's 30y squared. All of this over the original v, 10y cubed, the whole thing squared. So we're going to need to simplify this a little bit. So on the bottom, first of all, let's start there. When you square two things that are multiplying, you have to square each one. So it's 10 squared and y cubed squared. So on the bottom, 10 squared is 100. And for the y, when you raise a power to another power, you multiply them. So this is y to the 6th power. On top, well, there's a whole bunch going on up there. Let's see. You could multiply together, or you can factor. I'm going to start by multiplying, and then we're going to see if we can factor anything out. So 3 times 10 is 30, y cubed, and e to the y. So I'm just rearranging. I usually like to put the y cubed in front of the e. E is usually what I put last. That way it's very clear who's in the power of e. At least I think it is. Minus 3 and a 30 can multiply, so that's 90. And then we have a y squared and an e to the y. So by organizing number, then y to a power, then e to a power, it makes it easier to figure out what we can factor out of the numerator. So what's in common up there? 30 and 90. What can be divided into both of those? 30. Let's pull 30 out. If we pull 30 out, what else can we pull out? So we have y cubed and y squared. Always take the smaller power out. So y squared can come out. And then both terms on top have e to the y. Wow, we took a lot out. So for the first term, 30 is gone. We still have a y left. E to the y is gone. Minus 30 comes out of 90. That leaves us with a 3. Y squared is gone, and e to the y is gone. So that's all we have left on top. On the bottom, we still have 100 y to the 6. Are we done? No, we can still simplify. So 30 and 100 can both be divided by 10. So let's reduce that. Just cancel out a 0 from each. We have y squared. We can cancel out with 2 of the y's in the bottom. I think that's it. So let's rewrite what we have. We have a 3e to the y times y minus 3 all over 10y to the 4th. And there you go. That is the derivative of the original question. All right, I'm sure we're going to have more practice as we go through, but this is it for this video, and I've got second derivative and higher order derivatives coming up next. So study hard and watch your videos, and I'll see you in the next one.